Okay, so what I'm going to go through here today is how to think about constructing shaders, or how I think about constructing shaders in Reality Composer Pro shader graph. And specifically, we're creating this feathered edge around a mesh. This specific shader that we're working with here really only works with meshes with a lot of vertices and a lot of normals that blend. And I'll show some examples of it not working with other meshes. We're working with a primitive sphere, so you can see this is the default material that it would normally come with, attached to my shader. And the way to think about it here is that with these vertices that we have the normals of these vertices are all pointing sort of gradually away around the object. And we can use this information that's already in the mesh to create this effect. And how we do that is by using, let me zoom in there, or highlight. We have the view direction of the camera, and then we have the normal at that given point, which are those arrows that I just drew, and we're using a dot product to compare these two vectors. What a dot product does is, let's say we have the camera looking this way, and then we have the normal of the mesh, which could be looking this way, it could be aligned with the camera, it could be perpendicular, and of course it could be anywhere in between. A dot product provides, when it compares the two vectors, it gives you a value from 1, which is here. This is, so an aligned value, two parallel vectors, dot product will give a value of 1. If they're anti-aligned or anti-parallel, they are, it gives a value of -1, and then perpendicular gives a value of 0, and then of course any value in between. So any values that are, so this is an odd thing with Reality Composer. So if we go here, we can see the dot product. So anything that is aligned, which is this one, like the perfect middle, is opaque. And then as these vectors, so this is opaque, and this is perfectly transparent, and then you can see that it's fading out as the normals are changing. An odd thing with Reality Composer Pro is that it doesn't really handle negative values or greater than 1 values in opacity very well. So with, actually, no, it handles negative perfectly fine in this case. Greater than 1 is what it struggles with, which becomes an issue later on. So we're clamping this now between 0 and 1. We're not caring about any of the negative values, and they don't matter anyway because they're all behind this mesh. So you can see, so when we dot product it and clamp it, this is the effect that we get. When our target is looking like this, you can see that we really only want a transparent portion around the edge, and we want this to be fully opaque and matching the material color that we're working with. So to get from here to there is one easy thing is we can multiply our dot product by 3 in this case. So what this means is that this value here is going to be 3 instead, and this value here, which is 0.01, will be 0.03. But what effectively will mean is that anything above 0.3, which is maybe here, oh sorry, let me point it the other way, anything above 0.3 is now going to be 1 or greater. So let's plug that in and see. So that works pretty well. And this is where you can see that the opacity in this area is greater than 1, and Reality Composer Pro for some reason does something funny. It should be looking like this color of gray, but it is looking a little bit brighter. But we don't need to worry about that right now. But we're happy with the feathering of the edge here. So if I were to change this to 2, you can see that we have a wider feathering. If we go for a 4, we have a narrower feathering, and 3 seems pretty good. And then if we zoom in, you can see that even though the width of this feathering, so from here to here, is what we're targeting, the actual rate of the transparency disappearing isn't quite what we want. So you can compare it to here. You can see here we actually have a full, so ignoring the shine of the material, the gray gets transparent pretty quick, and it's much more stronger towards the surface, if we imagine this being the surface. So the way to do that is using this power node. What that does is the top input is x. So going here, the top input is x to the power of y, which is this fall off. And the fall off is set to 2. So this means that any value that is smaller than 1, so x gets multiplied by itself 1 time because of a fall off of 2. So if x is 1, 1 multiplied by 1 stays as 1, perfectly normal. If x is greater than 1, so let's say 2, just for the ease of maths, 2 times 2 is 4, so numbers greater than 1 are getting larger. And then if x is 0.5, multiplied by itself, the output becomes 0.25. So numbers smaller than 1, which are the ones that we care about, because everything from here to here is less than 1, decrease faster. And then any values above 1 stay above 1, which is what we want, because we want this area to stay opaque. So if we do that, you can see this has now gotten even more brighter because of the weird opacity issue in Reality Composer, because these numbers are much larger than 1. But if we just look at this transparent area, let me get rid of that, and we can compare. So you can see here the gray, I can still see gray out here. Once I plug the power curve in, it really, it's a very fine difference, but I notice it, and it feels a little bit more, it feels a little bit nicer now. And then finally, we want to fix the opacity where this shouldn't be quite so bright, so we clamp the value between 0 and 1. And there we go. And so this fall off, if you're curious, is just a input. So you can add an input here, for example, for the multiply. So let's say this is a feathered size. You can set it to a float. Add that. And then you get this float here. So I can set the default to 3, for example. Plug that in here. And now I can adjust the feathered size in this location. You can see 1, 2, 3, 4. Now I'd like to show some examples of this shader being very dependent on the type of mesh that you have. So if I activate this cube is also using the same shader. But you can see here, whereas we had a lot of different vertices with normals on this one, on here, what we likely have is normals like this, and then some normals over here like that. And then, so every vertex just having these 3 normals and nothing in between. So if I'm looking at it directly on, you can see that there's no transparency. There's no softening of the edge anywhere around here or here. But then as the normal, especially sort of the normal here, is compared to the camera, it starts fading out that whole side of the cube. So this one with no rounding of the edges or anything really doesn't work with this shader. And then if I activate a cone, you can really, it's a nice comparison between the two. Whoops, sorry. So here, I've forgotten how to, there we go. You can see that the normals around the sort of spherical part of the cone are great. You get a little bit of a feathering of the edge, but then suddenly once you get to the corner, you just got these two normals, and that's why you have a hard edge here. And you can see that the normals are not very different here, so around the point as well, it's not as soft, and it softens out as the normals spread out. Yeah, I hope that's a good explanation for dot product, how you think about shaders, as well as how to create something like this.